In the silent expanse of the cosmos, where time stretches endlessly and the darkness is broken only by distant stars, the seeds of both creation and destruction are sown. The universe, vast and mysterious, is a stage for forces beyond our comprehension, forces that have shaped galaxies, worlds, and the very fabric of reality itself. Here on our fragile world, explosions are not just moments of chaos, they are the architects of change. From the fiery birth of planets to the violent impacts that have scarred our surface, these bursts of energy have sculpted the Earth and continue to influence its destiny. Explosions are the universe's most dramatic expression of energy, unleashing power that transforms, expands, and reshapes everything in their path. Whether natural or man-made, each explosion tells a story of energy released in an instant, altering the world forever. Today, we'll embark on a journey through the ascending orders of destructive power. We'll start with the smallest human-made blasts, controlled, calculated, and often spectacular in their own right. Then, we'll witness the planet's own fury, volcanoes, storms, and natural disasters that dwarf anything we can create, reminding us of nature's raw, untamable strength. And finally, we'll look beyond our world to cosmic cataclysms, supernovae and galactic explosions that release more energy in a moment than our sun will in its entire lifetime. To truly grasp the scale, we'll compare each explosion to a single stick of dynamite, our baseline for understanding the unimaginable forces at play. From the familiar blasts that have shaped history to the unimaginable forces that have altered the cosmos, we'll explore the science, the stories, and the profound consequences of the most powerful explosions ever recorded. This is the story of power, measured, compared, and understood. Join us as we unravel the mysteries behind the genesis of destruction and discover how these explosive events have shaped our universe. Our journey into the world of explosive power begins with something deceptively simple: a single stick of TNT. At first glance, it might look unremarkable, just a small cylinder wrapped in paper, resting quietly on a rock or lying in the dirt. But this humble stick is the foundation for understanding the immense forces we're about to explore. TNT is the gold standard for measuring explosive force. Whenever scientists or engineers talk about the power of an explosion, they compare it to this very stick. It's a universal yardstick, a baseline for destruction. Each stick contains just over 4 megajoules of energy, an amount that's hard to imagine. That's enough raw power to launch a car through the air, or reduce a solid concrete wall to rubble in an instant. In slow motion, you can see the sheer violence unleashed in a fraction of a second. The explosion is sudden, brief, and intensely local. Debris flies outward, dust clouds billow, and for a moment the world is transformed by a burst of energy. Its shockwave can shatter glass from meters away, and the fireball burns with a heat that's impossible to ignore. But as powerful as it is, the destruction fades quickly with distance, leaving only a scar on the Earth. For miners and engineers, TNT is a trusted tool, powerful, reliable, and precise. It's used to carve tunnels through mountains, break apart stubborn rock, and shape the world to human needs. On a human scale, its force is nothing short of impressive. Yet, when we step back and look at the bigger picture, this stick of TNT is just a whisper compared to the thunderous blasts that lie ahead in our journey. Every greater explosion we'll encounter is measured in multiples of this humble stick. It's our starting point, our reference, and the first step toward understanding the true scale of explosive power. Now, we multiply our baseline 1,000 times, a metric ton of TNT. This is the scale of major demolitions and conventional bombs. 4 gigajoules of energy. The fireball is massive, the shockwave a deep, chest-thumping boom. Craters form, buildings shatter, and the blast can flatten a city block. The destructive radius grows, the consequences more widespread. This is the power that shaped 20th century battlefields, yet even this is dwarfed by what lies ahead. World War II brought a new weapon, the Grand Slam, a 10-ton TNT equivalent earthquake bomb. This massive bomb was designed to penetrate deep into the Earth before exploding. Its genius was in design. Dropped from high altitude, it burrowed deep before detonating. This allowed it to create a massive underground explosion. The result, a subterranean shockwave that collapsed bunkers and shattered foundations. The power of the explosion was magnified by the Earth itself. It didn't just destroy targets. It undermined the very ground beneath them. This was strategic destruction, using geology as a weapon. The Grand Slam was a game-changer in warfare technology. The Grand Slam marked the peak of conventional explosives. It was a symbol of human ingenuity and destructive power, but it was also the end of an era. The world was on the brink of a new kind of warfare. A new, far more terrible power was about to emerge. The atomic age was dawning, changing the face of conflict forever. July 16, 1945, Trinity. The world's first atomic explosion, nuclear fission, not chemistry, unleashed 20 kilotons of TNT equivalent energy. The fireball vaporized steel, turned sand to glass, and birthed the iconic mushroom cloud. A single bomb now equaled 2,000 Grand Slams. Oppenheimer quoted, "Now I am become death, the destroyer of worlds." The atomic age had begun, with power to end not just battles, but civilization. Trinity was a demonstration, a warning of what was possible. The world would never be the same. Less than a month later, theory became reality over Hiroshima. Little Boy detonated, releasing 15 kilotons, flattening the city, incinerating everything within a mile. 3 days later, Fat Man struck Nagasaki with even greater force. Tens of thousands died instantly. Many more suffered from radiation. Over 200,000 perished in total. These were not tests, but attacks, ending World War II and beginning a new era of fear. The images of Hiroshima and Nagasaki remain a permanent warning. Nuclear warfare had arrived. The Cold War escalated with the hydrogen bomb, Ivy Mike, 1952. Nuclear fusion, the power of the sun, unleashed 10.4 megatons, 10 million tons of TNT. The island of Alujilab vanished, replaced by a 2-kilometer crater. The mushroom cloud soared 40 kilometers high, spreading fallout for hundreds of kilometers. The era of kilotons was over. Now, there was no upper limit. Humanity could now destroy not just cities, but continents. The doomsday clock ticked closer to midnight. The world had entered the age of the megaton. The Soviet Union's Tsar Bomba, detonated in 1961, was the largest ever. 50 megatons, 10 times all W3 explosives combined, unleashed in a single blast. The fireball was 8 kilometers wide. The shockwave circled the globe 3 times. The mushroom cloud soared 64 kilometers high. The bomber barely escaped. The heat could burn skin 100 kilometers away. Tsar Bomba was militarily useless, too big, too indiscriminate. It was a political statement, a warning to the world. Afterward, nations stepped back from the brink. Nature's power dwarfs our own. Krakatoa, 1883. A volcanic eruption equal to 200 megatons, 4 times Tsar Bomba. 2/3 of the island vanished. The explosion was heard nearly 5,000 kilometers away. The pressure wave circled the globe 7 times. Tsunamis wiped out villages, killing over 36,000. Ash darkened skies, cooled the planet, and created blood-red sunsets. Krakatoa was a reminder, the Earth itself can unleash apocalyptic force. Human power is small by comparison. Tambora, 1815, history's largest recorded eruption, 800 megatons of TNT equivalent energy, dwarfing Krakatoa. The mountain lost a kilometer of height. Ash soared 43 kilometers high. Immediate devastation killed thousands, but the aftermath was global. Ash and sulfur dimmed the sun, causing the year without a summer. Crops failed, famine spread, and tens of thousands more died. The eruption triggered the worst 19th century famine. A single volcano changed the world's climate and history. Yellowstone, an American supervolcano, a sleeping giant. Its last eruption released over 10,000 megatons of energy. If it erupted today, the blast would annihilate the region and blanket North America in ash. Global agriculture would collapse. A volcanic winter could last a decade. Civilization as we know it would be threatened. The odds are low, but the potential is humbling. Planetary forces still shape our fate. 66 million years ago, an asteroid struck Earth. 100 trillion tons of TNT equivalent energy. A crater over 100 kilometers wide, mega tsunamis, and global firestorms followed. The sky darkened for years. Photosynthesis ceased. Food chains collapsed and the dinosaurs vanished. This single explosion reset life on Earth. The age of mammals, and eventually humanity, began in its aftermath. cosmic impacts are the ultimate agents of change. The supernova, the death of a massive star, is the universe's most powerful explosion. In seconds, it releases more energy than our sun will in 10 billion years, 10 octillion tons of TNT, numbers beyond comprehension. For a moment, a single star outshines its entire galaxy. Supernova forge the elements of life, gold, iron, calcium, scattering them across the cosmos. We are stardust, born from these cosmic blasts. The supernova is both an end and a beginning. From dynamite to supernova, explosions are the universe's punctuation marks, moments of violent transformation. They end eras, create worlds, and shape the cosmos. Each blast, whether human or cosmic, tells a story of energy unleashed. In understanding